Hello, good day, everyone. Welcome from all over the world. Thank you for joining today in our Design and Technology Conference 2.0. Uh, we began this conference last year, and now we are having the second edition. This second edition promises to be insightful, engaging, and diverse as we have an array of speakers from different disciplines: architecture, engineering, construction, MEP, name it, graphic designs, security, cybersecurity, experts. And so this year's conference promises to be enriching and engaging. I want to thank you for joining. Now, the aim of the conference is essentially to foster innovation within the design and construction industry. We hope to do this by interrogating problems from a multidisciplinary perspective. Want to engage from different perspectives and different approaches to the issues around innovation in construction and design. And so, want to welcome you and thank you for joining. And right away, we'll be kicking off. Thank you very much.
Meet Dr. Gbenga Alalade, who will be speaking on accelerating innovation in architecture, engineering, and construction. Gbenga holds a PhD in architecture with a special interest in architectural structures. His interest in architectural structures sparked his flair for long-span and large-scale buildings. He is the project director and lead architect of the 100,000-seat stadium-like sanctuary, the Arc Legacy Project, which would be the largest covered stadium structure in the world upon completion. Gbenga focuses on connecting people by creating smart and sustainable buildings and cities. He has led the design and construction of several large-scale and infrastructural projects across Nigeria and a few African countries, ranging from stadiums, megachurches, shopping malls, airports, high-rise buildings, educational facilities, housing estates, road construction, wastewater treatment plants, and power plants, among others.
Thank you. Thank you very much, uh, the Job Design team, for that brief bio. And I think right away, I'll be going into my very short session. Mine is a very short session. My job is very simple. It's just to introduce this conference, and I'm sure we can take it up from there with uh, you know, our panel of speakers. Like I mentioned, we have a large plethora of speakers from different disciplines. And so I'll just take my session and welcome you. So thank you very much. And as I progress, so just trying to share briefly on accelerating innovation in architecture, engineering, and construction. It's interesting that a profession like ours that prides itself as a hub of creativity, there's a blind spot, a very interesting one at that. And this blind spot is that professionals who are trained in creativity, architects, engineers, planners, we belong to one of the least innovative sectors in the global economy. That's a paradox. And that's why I've titled my paper, The Creativity Paradox. We are the guys, we are the folks who are seen as creative, trained in the art of creativity. And yet, we belong to the least innovative sector in the global economy. Now, this paradox is not normal, it's not philosophical, it's structural, it's economical, and it's cultural at the same time. And the point is, if we don't address this challenge, this blind spot, we may soon be like the dinosaur, who, in their large scale, in their each size, after a while, they just moved into extinction. That may begin to happen to the design enterprise, the construction enterprise, if we do not reinvent ourselves, if we do not address this blind spot. And so that's a major blind spot at the crux of my discussion, this afternoon. And of course, as I progress to my next slide, I'll be looking at new dimensions within this same concept. Now, it will interest you that in the 2017 landmark study by McKinsey and Company, they realized from their study that even though our profession, our industry contributes 13% of global GDP, we have only achieved 1% productivity in the past 2 decades. Now, if you compare this to the global economy, 2.8% increase or growth, compared to manufacturing, you have 3.6% in manufacturing. If you compare it to the high tech sectors, you have 4.1%. And yet, the industry that contributes 13% to global GDP, the industry that is founded, that is based on creativity, only has 1% productivity. That's a paradox. That's the paradox. Now, it's a major gap. Now, this gap becomes more interesting and perplexing when you realize that architects are trained to think divergently, to imagine the unseen. I mean, engineers design complex structures, large span, long span, solve complex problems. Builders can put together different materials, they can, harness human resources, and yet we are unable to break through productivity in our industry. And so, uh, and yet we also live in the industry where we can literally have 1.6 trillion dollars in addition if we are able to just become more productive and more innovative. And so the issue around creativity, our creativity as professionals has not been translated into systemic innovation. It's just been redundant within the silo of our profession. And so this gap needs to be addressed. And like I said, this is the focus of my presentation today. And so going further to to explore this gap, I mean, as you can see on this graph, the hourly rate for construction, $25, 1% productivity growth. For the global economy, about 2.7, 2.8%, and that's about $37 per hour in terms of wages. Now, and for the manufacturing sector, it's about $39, about 3.6 percent growth, right? And for tech, about 4.1%. Now, that's an irony. That's an irony. It's a paradox. We are the guys who are most creative, and yet when it comes to translating that creativity to innovation, it becomes a problem. And so we explore further on my first slide. And so the question is, why does this gap exist? Why? Well, a number of reasons, but I'll just try to zoom in on three here. One is the industry is fragmented. We have the project owners, consultants, contractors, suppliers, subcontractors, especially subcontractors. Now, and each of these groups of persons, professionals, we are working in most times working in silos with misaligned incentives. And so this becomes a major reason why innovation does not exist within our industry. And that's because a lot of fragmentation. Of course, you also have risk aversion. Okay? Now, please, back to the last slide. Risk aversion. We are always keen on, if it's not broken, don't fix it. I mean, with this, we are keen on reliability. Oh, it must be stable, it must be structured, and of course, cost control. We are unable to experiment. You find folks in the tech industry, in manufacturing, coming up with new products, new ways of doing things. But most times for us, we are stuck with, oh, the code. The code says so. It got to be so. Of course, procurement and contract, a very interesting part. The lowest bid wins the contract. And this oftentimes discourages innovation. You may have a bidder with a more creative, a more innovative approach, but because the lowest bid wins. And so these are fundamental reasons, among others, why innovation deficit exists in our industry. Now, creativity is not the problem. We are creative. I mean, all through your training in the uni, creativity is at the core of the training of designers. But the issue is more about the systems. Okay? Now, we are creative in form, but usually we are conservative in process. If you observe literally every project, the same routine of design, the same routine of specification, the same routine. So in most times, yes, new challenges, but we are approaching those challenges with the same processes. And so this in itself is a killer of innovation. And so really the problem is not about the absence of creativity, rather is the absence of mechanisms to convert creativity into innovation, which has been at the core of what we do. And so I would like to just look at about three case studies that highlights a something of innovation gap. And I'll just take very simple, I'll call them it's very simple gadgets. If you do a comparison between the television set and a water closet was, developed, the flushing system was developed about 300 years ago and more. Now, if you compare that and the growth of the WC, its evolution. If you compare it to the television set, the TVs were first developed in 1927, about 100 years ago. But in the last 100 years, I'm sure we have seen how TVs have moved, how they've evolved over the years. Okay, you have widespread color adoption, you have LCD, you have plasma. Now, much more than that is the value creation of the equipment or the outside item called the TV. Today is worth over $250 billion and has created new ecosystems like streaming, digital advertising, content creation. Whereas the toilet has literally remained stagnant, has literally remained but just functional. You just see different manufacturers coming in with different curves, different shapes, designs of the toilet, and yet the toilet has not evolved. Okay, so TV has become a smart, adaptive, technology. The toilet has remained in its functional state. Okay, Bill Gates once remarked about it. He said, "Look, everything we have made progress in everything except toilets." That's an expert in technology who has devoted his life to the health sector. Say, hey, it appears we have made progress every other place, but in toilet, this box or this cylinder, this equipment still remains the same way, the same flush system. Okay, you can imagine the X strap was patented in 1775. Since that time, it's literally been the same. Nothing really significant in terms of its function and change. Okay, my next slide. Thank you. Now, another product is the smartphone and the brick. Just some random comparison that gives us a sense. And these things have been about 50 years, 100 years. Okay, smartphone. We had the typical analog phone. Smartphone came up in about 2000 and 2000 year about. Within that, within the last 25 years, the smartphone has evolved dramatically, astronomically. But our brick has literally stayed the same in the last 2000 years. And so we can see the way smartphones have transformed from luxury to life essential tools. People can't just do without their phones. But the building blocks for cities have barely changed. And we are still using, the elements we used, you know, about 2 million years ago to still build mega cities in the 20th, century. And so I'm sure now we can see there is a gap if we compare these elements. The third case study is about uh, automobiles and building assembly. If you compare the way the vehicle has evolved. Okay, from the 14 model by Henry Ford and building assembly. Okay, the 14 model has evolved in the last 100 years. We can say that even today we now have cars that 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 work are driven by operating systems. You have EVs everywhere. You have autonomous vehicles everywhere. Now, R&D alone in the automobile sector is about 2 to 6% of annual revenue. Now, the same is not with construction. The building system has remained literally the same way over the decades, the same way. Okay, so these are areas. This is just to give us just a sense of how other industries have evolved. I've shared about the TV, that's media. Okay, I've shared about the phone. I've shared about WC, and so it gives us a sense of how other industries have evolved. But construction, design, we are literally just moving and not progressing much. All right, next slide, please. And so, just to also give you a sense of, oh, yes, are we actually having some bit of innovation in design? Oh, yes, we are. I mean, example, a global view will give us we have modular construction in Sweden and Singapore. Of course, this has led to about 40% of new homes use modular methods. In Singapore, the prefab homes, pre-finished volumetric construction, this has given rise to about 30% in time saving. In the US, you have AI powered design in the US, okay? Digital twins in the UK. Obviously, there are some signs of innovation. I mean, we have some firms, some organizations that are taking the lead, but there can be more in terms of the gap between construction and design and other industries. Quickly, next slide, please. Yes, the next slide. Now, for Africa, we stand at the threshold. By 2050, in 25 years' time, Africa will need about 7 million new housing units. Nigeria alone has about 20, 30 million housing units deficit. Now, and yet, with this kind of shortfall challenges, only 20% thereabout of companies in AEC in Africa, I mean, in Nigeria, are using digital tools. And so we can see that dichotomy, that contrast. And so it's not about a technology problem, it's more of a leadership challenge. And this calls for professionals to be system thinkers. I think we need to think beyond our profession and think a system and think problem and think solving problems. Not just think, oh, I'm an architect, I'll just design buildings. No. We should think how can we solve problems at scale. And next slide, please. Next slide, please. And so, how can we break this paradox? 5 quick things. Now, we need to begin to think from projects to products. Now, we have been designing buildings over the years. It's time we think of buildings like products, where we can have repeatable, upgradable modular systems. And of course, we can take a cue from the tech firms. You will see iPhone 6, iPhone 7, iPhone 8, and like that. And you can see that, oh, one same iPhone, you have iPhone Pro, iPhone Max. Now, we need to think of buildings in that regard. From analog craft to digital mastery. Oh yes, we have tools today, tools such as 3D printing, robotics in construction. Now this needs to become the norm. Now, this shouldn't just be case studies in Europe or a part of the world. It should be the norm if we want to really be innovative in our industry. And of course, we must not see technology as a field, as a domain. Rather, we should see technology as a medium for communication in business. Okay, we must go from the star architect syndrome, okay, or star designer to fostering collaboration. That's where the genius of our work is. The star architect will someday, you know, go extinct. Star designer will someday go extinct. But if you have built a team, this team can always scale innovation. They can scale solutions, right? And of course, we must go from the lowest cost to the longest value. The idea of, oh, the lowest bidder wins the project may not always be the solution. Rather, to look at which solution will give the client the longest value, optimum value. Quickly, I have a few more slides before I tidy up my. And so, just a very simple case study. Of course, the ARC project, for instance, also have had its own challenges, but we had to reimagine collaboration. I recall at the time, our design office, we were working both remotely, okay, also working in a physical location, right? We had to co-work because no one single architect, two architects can get the job done. So you have to work on the same project on several systems. You have to have a workflow using Beam. Of course, an amazing part is that we also had challenges with procurement, and we had to break the norm. Okay, we had to reinvent relating not just with installers, relate directly with manufacturers. Now, these approaches help the client to record huge cost savings. Of course, we also have to fight the forex matters. Those were critical issues. Of course, in all of these, we had to reinvent our approaches. Oh, at a point, institute, construction. At another point, precast. All of these things put together. At the point, we had to even, optimize using steel structures. And with this, we're able to gain certain amount of speed on the project. And so that's just somewhat some kind of case study. I think I should just mention as we progress. Of course, as you can see, the structure is emerging. And so as I begin to wrap up my conversation this afternoon, depending on where you are in the world, for some of us it's this morning. Uh, I think government needs to mandate BIM. Now that may sound utopia in nature. Now that's one way to start. Government needs to mandate BIM, even at the point of building approvals. Imagine if all approved, approval, drawings are BIM enabled. Architectural drawings, structural services, all on one platform. You can imagine how much time that will save. Of course, educators, we need to bridge the gap between creativity and technology. How do we design and how do we intend to construct? That gap needs to bridge, to be bridged. And educators can do wonders in that area, particularly when it comes to BIM adoption. Of course, professionals, we should demand better tools, share better methods, and of course, design differently. And of course, to clients and developers, interestingly, you need to stop asking just for beauty and cost. You must ask for performance, resilience, and adaptability. It's not about one cap fits all. No, let your designers, let your consultant produce for you high performance building. Demand for it, not just aesthetics, not just cosmetics, by the way. Well, I want to say thank you very much. It's a very short presentation. I just felt I should give a background to this conference. I'm sure we have picked a couple of two things, and I'm sure that this for us will be an era of creativity, an era of innovation. I want to thank you for joining, and our speakers are set. I want to thank you. I'm sure in the next couple of minutes they will take the stage and run with the conference. Thank you very much, everyone. Once again, you're welcome.
Meet Dr. Hassan Anifowose, who will be speaking on digital transformation in AEC, architecture, engineering, and construction. Dr. Hassan Anifowose, a highly skilled architect and VR developer, holds a PhD in construction science from Texas A&M University demonstrating his expertise in architecture, visualization, and construction. He is the founder of Kronos Studios, an internationally recognized design and visualization company. He serves as the VDC manager at Clark Construction for the $2.5 billion Houston Terminal B Airport Transformation Project. He specializes in producing immersive training simulations and educational experiences, leveraging his deep understanding of architecture and design. Hassan is committed to exploring innovations in BM, virtual reality, mixed reality, and artificial intelligence, while also mentoring aspiring entrepreneurs and enhancing project performance through digital twins.
I am going to go ahead and share my screen. Thank you. Hi everyone, and good afternoon, good morning. Confirm you can hear me all loud and clear, and you can see my screen. All is good to go. Today I'm going to be talking about digital transformation in AEC, architecture, engineering, and construction. I'm going to be highlighting 5 digital forces that you need to reckon with. And then at the end of my presentation, I'm going to be, giving you some takeaways of what to be on the lookout for in the future. So without further ado, I am going to begin. Quick introduction about myself, as the intro said. So I'm gonna, skip on this very quickly. Co-founder at Kronos Studios. I'm also VDC manager at Cloud Construction. Being a construction technology expert, I run the virtual design and construction unit in Houston, which is the central region. And majority of my focus is on model coordination between all the trades on very complex projects. I also support some other projects on the West Coast and on the East Coast. So in addition to what I do primarily, I also initiate, I'll call it pilot sessions for virtual reality. I do take a lot of field capture technology efforts on, and I also deploy drones for project as needed. So here we go. I'm going to say with this statement, a very bold and open statement here, in the digital transformation in AEC is here to stay. It's not something we're going to fight. It's not something we can avoid. It's not something we can shy away from. I know Dr. Gbenga had shown, the innovation between the television, the toilet seats, and you can see how far the AEC industry is behind in innovation. However, I think we're catching up a little bit, and I think there's been some significant growth in the past couple of years. And I'm glad to say that as of today, nearly every tool or process that I use is accessed from the cloud. Nearly everything. I literally can go from point A to point B with nothing, maybe except a mobile phone, and all I need is to latch onto the cloud, and I have access to everything that I use to get my stuff done. So that is something that we all need to start thinking about. And I'm talking, cloud access. So here is some statistics from an Autodesk report that says over 70% of construction firms now use cloud-based collaboration tools. And if you compare that to what the report said in 2020, it was 30%. So what happened? What spanned this much growth between 2020 and 2025? Of course, there was COVID, right? And everybody was at home, indoors, couldn't go to the job site, couldn't go to the office, things like that. And we learned how to collaborate online, right? And this is a very, very good indication that the construction industry is waking up. And I think it's the responsibility lies on each and every one of us to push a lot of this innovation. You might find out that most of my presentation content today is going to be construction related, just because that's where I'm my most recent endeavors are focused. However, I do still have a very, very strong design background, value engineering background. So don't think that I'm trying to like shove construction down your throats, but that's just a reflection of where my most current efforts are today. All right. So again, in Dr. Gbenga's opening, he mentioned about the government mandating Beam, and there is nothing more true than that. In fact, at the point it started to look like we talked about our presentations, right? No, we did not. I'm just watching his presentation live as well. BIM, which stands for Building Information Modeling, for people who do not know, is the backbone of the AEC industry. And the reason why I'm highlighting the high is that information is what really, really makes Beam to be Beam. It's not the model. It's not sitting behind the software. It's actually the level of information that is inside all of the assets in that design or in that project. And that information right now is what I can tell you is driving a lot of the innovation that we're getting today. So Beam should no longer be an option. It should be a standard. And yes, if there are policies in place that ensures or enforces that this is the standard for all projects, I think that's going to do the AEC industry a whole lot of favor. So if you're a policymaker, if you're in those corridors of power to make those decisions, I'm begging you to please start to push for Beam adoption in everywhere, in the schools, in the workplaces, in the government parastatals. Let's try to make it the benchmark, the basis of everything that we're starting off on if we're going to talk about being innovative. So let's talk about Beam and its integration across project life cycles. Beam doesn't typically end at the design phase or the costing phase. In the early phase, that's not where Beam really ends. Beam gets extended into the entire path of a project lifecycle. And the first one I'll talk about is construction coordination, which enables us to have detailed planning and sequencing and helps construction teams to avoid clashes and reduce rework on site. Don't let anybody tell you that, oh, I've been building for 25 years, Beam is just another fancy word. I bet you that person is not efficient. I can tell you that for sure. That person is accumulating a lot more work, accumulating a lot more change orders or client cost that impacts the client. That person is not working very smart. Okay, so don't let anybody tell you, oh, I've built for 30 years. Beam is just another fancy thing. No, they're not building efficiently. With Beam, you can literally make your project experience superpowers of all the capabilities that Beam has to offer. Okay, we're talking 4D, 5D simulations. You can start to simulate time and cost with how your building is going to be built, how much cost your client is expected to spend at a certain time, maybe in the finishing stage. That helps them to drive information about how much money we need to be asking the bank at this phase, right? Just because of the comparison between the time and the cost. So beyond the 3D model, we're talking extensive integration of other dimensions, which is time and cost, and having that embedded into the information that you have inside your building project. That is how you can start to make really, really smart decisions. And guess what? Your client comes back when you're able to help them win and save money and still be very efficient. So for prefabrication, one thing I'll tell you is a well-prepared project that has really, really utilized Beam can manufacture offsite and just ship and assemble. That is a huge plus when it comes to project timelines. Majority of projects, when you start fabricating on site, when you start making things, putting stuff together on site, that is something that is going to take a lot more time than anticipated. So one other thing is that your client likely now has BIM requirements. Okay, so if you start working for large corporate companies, there's a high probability that they have BIM requirements based on maybe their corporate head office rules and things like that. So it's best for you to prepare yourselves to have those type of clients and work with them. Okay, so the second one is cloud and collaboration platforms. So cloud tools definitely allow all the project stakeholders to start to work on the same tasks and the same models or the same data in real time. And the power of maybe we've all experienced the power of Google Docs, or Google Sheets, Google Slides, having two or more collaborators at the same time. And now imagine being able to work across different time zones, right? Maybe you have a supporting team in Japan, or on the East Coast, or Dubai, or the United States, or Nigeria, or Abuja. Being able to collaborate from anywhere is super, super important these days. Collaboration, again, Dr. Gbenga said, collaboration is key, right? And today, that is one of the major deciding factors of being successful in the AEC industries. If you can efficiently stop working in a silo, whereby that work is dependent on one person taking a laptop, taking a file, moving from point A to point B, that effort starts to depend on teams working from anywhere, working at any time, and having real-time access to a model or information. That is where your teams should start going. So if you're working in a company, start pitching that to your superiors. If you're leading a team, start pitching that to your subordinates. Let everybody start to understand that being able to collaborate on cloud, on platform tools, is going to be a big game changer for everybody. Okay, so don't get left behind. Automated change tracking also helps people to understand who did what, right? Who changed what? Who fixed what? A lot of times, if you set up your project in such a way that you have basic beam execution plans or rules that says in a certain way, files are named this way, sheets are named this way, elements are named this way, assets are named this way. It really, really helps everybody to understand what the standards and requirements are, and then able to deliver to those standards. So it's not just working in the cloud and doing anything. There have to be rules that would support that process. Okay. So you can Google, BIM project execution plans, right? Those typical templates you can find online, and those would really help set up your project for success. Because one thing about collaboration online is, if you do not define the rules, people are bound to step on each other. People are bound to override each other's works. Again, depending on how your environment is set up, your CDE, your common data environment, depending on how that is set up, you can avoid a lot of reworks and actually use the power of real-time collaboration. So read the rules, execute the rules, and you're going to be fine. All right. So some of the tools you might start looking at, Revit Collaboration Pro. Of course, you need a license for that to be able to do cloud work sharing in the file. You can learn Autodesk Construction Cloud. If you go to, I think, learn.acc.autodesk.com. I think I'm not certain about that URL, but if you Google Learn Autodesk Construction Cloud, you will come across a whole course load of content that helps you understand how cloud collaboration works for Autodesk platforms. Procore, being able to share the design sheets or drawing files, BIM 360 are the same, docs, being able to collaborate on live document, create markups without having to attach files to emails and then losing track of changes, right? Being able to work in one place is a big deal. All right, so let's talk about field automation and machine vision learning. Robotics do, here is a quick short video of that I took of one of the construction robot dogs that basically can help to inspect a job site and kind of identify your safety observation reports, identify risks or hazards on your job site, being able to take pictures of construction work ongoing, progress pictures, identify hotspots, dangerous work being done. That is a game changer again. And again, because of how these robots are designed, they can collect an immense amount of data, right? That can be fed back into your design or your project. That data can also help your field teams, your safety teams, your inspection teams to make very, very informed decisions about what is actually going on the job site. With sensors, mobile apps, we have data collection going on an exponential scale right now. We have workers being able to wear like a simple wristband, and that data can get transmitted to a workforce manager or a foreman who can tell if his workers are getting tired in a specific area of the job site, right? Just by looking at some charts, they can tell if this person's gait or stamina is slowing down or changing, or this person even just had a near miss, right? They almost fell, they almost lost their step, or they almost fell. All these sensors on, wearables are starting to change how field work is done. Dusty Robotics, I was opportune to meet their directors in Denver. The key director in Denver, I think 3 years ago. Very pleasant woman, very amazing woman. Dusty Robotics is doing absolutely amazing stuff, helping to lay out, say, walls on a job site. So you have your slab on grade, or you have your concrete deck, and you want to start laying out your walls, right? If you feed your floor plans into that robot, it basically just goes out creating the layouts for you. Boasting Dynamics as well. You might have seen Spot the Dog. That is something that has gained a lot of traction. Did I lose my slide? Okay, so let's talk about autonomous drone mapping. Drone maps create can help understand construction progress. If you align that with design documentation and 3D models, you can start to map out site utilities, how it's laid out, equipment, site usage, and one of my favorite features of studying my post capture drone map is how you can use that to count and measure volumes of sand on your site, volumes of equipment, or even the number of vehicles on your job site to actually plan for an evacuation procedure. Um, there is so much you can do with drone maps. And excuse me, here was a picture of me initiating an autonomous drone flight, and that drone flight is pre-scheduled, is pre-mapped, which means that you're going to tell the drone where you want it to go, how many pictures you want it to take, where you want it to stop and take pictures, what type of pictures, what directions, and you just let it do its thing, right? The only thing now you're doing is supervising that operation, where typically in the past, you probably would have to like take pictures, maybe climb a high place, take pictures, or even fly a drone manually and all of that. Now there are systems that are super, super intelligent that can help with all of that. So drone deploy, these are leaders in the space. Flypix AI, DJI Terra, depending on the type of drones that you use, some of them also come inherently with automated autonomous capture tools, and you may not need third-party software. So for progress tracking, again, autonomous drone mapping and progress tracking, they're subs on that the field automation. So for progress tracking on the job side, this has become easier, especially with 360 capture tools. And the fun thing is that you can align those with your BIM models and actually start to check for discrepancies. You can know if a trade is not building in the right space. So if you've coordinated a model, or you've coordinated all your disciplines, your architecture, engineering, structural engineering, mechanical, plumbing, fire, you've all coordinated everybody in the right place, right? And then when you take field capture, 360 capture pictures of your job site, you can actually overlay them with your BIM models and see if anything is wrong. You can start to address that very quickly, especially if you have very frequent field capture days, which means that you can reduce the amount of rework that has to be done. If, for example, somebody misinterpreted a drawing and put an element in the wrong place, you can quickly detect that. And when we're talking about the AI-enabled portion, OpenSpace, Disperse, Hexagon, Doxel, these are leaders in the space, and they do very good job tracking construction progress on your job site. So coming to the last one, or maybe second to the last, smart design and sustainability. With digital tools, you can simulate building performance early. You can know how much water your building is going to use up, how much energy is going to use up, what your carbon benchmarks are, even up to where you can determine the method of construction based on your carbon projections, right? You can select low impact materials. You can start to learn how using offshore assembly or offshore fabrication is going to help your carbon footprint, right? So Autodesk Forma is a great entry point, especially if you're trying to like do generative design. I recall I had a task. We had an open ground where we needed some equipments to be shipped and laid down, right? And we needed a specific type of parking, which is bigger than the conventional parking, because if you're expecting 18 wheelers on a site, their turning radiuses are bigger than the regular vehicle. You know that these big construction trucks have larger parking spot requirements, and Autodesk Forma was something I just off the top of my head just went straight on to. I provided all the parameters, and with the test parking tool, you can actually start to automate or configure parking spaces depending on the parameters you create. Originally, the way you'd go about this is that you would, kind of start to draw lines and offset lines and then array and mirror and do all of that. But no, you don't want to go through all of that now, because if you do not embrace like faster design tools, you're basically going to be losing money to the next guy who is able to do that. So go ahead and learn Revit, learn Rhino Grasshopper. There's a plugin Rhino inside that works with Revit. You can actually use that to start your automation or your generative design learning curve. It's a little bit steep, so give yourself some time and grace. But I tell you, once you start, you don't want to go back. All right. So the last one is digital twins and assets. So beyond 3D models, integrating real-time data from sensors and systems to mirror the building's behavior starts to get important. You're able to determine things like humidity, airflow, temperature in your building just by having sensors across the building. Someone from 20,000 miles away can actually manage the building without having or to ever step foot in it, because of how much data is already included in your building model and how much you're able to integrate all of that, all those sensors and data into a system dashboard that can help you to monitor all of these assets. Facility managers are starting to get a hang of this, or starting to hop on the bandwagon, because of course it helps them to optimize energy use. If the occupancy of a building is dropping to 20% at the close of business, why do you have to leave all the lights on? Why do you have to leave all the generator supply or power supply on in that entire place when you can cascade that use just because of how much data or information you have to be able to do that? So that's what we're talking about: live data and digital twins. So there is a building and it's got a digital twin of itself somewhere on the cloud, somewhere in the model, and you're able to control a lot of things remotely using all of the data and information that you have in there. Sounds like utopia, right? Yeah, but Autodesk Tandem is leading the charge on that. I've been opportune to do some testing on Autodesk Tandem in the past 3 weeks, and I can tell you guys, it's the way to go when we're talking about facility management for the future. So what's coming? Last slide. What's coming? What should you be on the lookout for? Seamless integration or cross-platform APIs. You can expect platforms to start to unify design, cost estimation, scheduling, and procurement within a single environment. And I can tell you, Autodesk is trying to do that. Autodesk is trying to lock everybody in. Procore is trying to do that as well, whereby you can do all your sheets, document management, your scheduling, your RFIs. You can request for information from the design team. You can issue submittals. You can do quality control. All of that within the same environment. That is something you can start to think of is going to happen, and it's going to become the norm, in the future. For value engineering, architect Dr. Gbenga also said something about value engineering. AI-led value engineering will gain more traction, and tasks are going to be faster and cheaper, because now it doesn't cost you 20 days to do one thing, it costs you 3 days. So you might end up just charging for 3 days eventually. And think about the evolution from hand drafting to CAD to BIM. Now we're able to build more complex projects in shorter times, right? So when the data from past BIM projects starts getting fed into platforms that use AI, they can actually value engineer a building and say, no, it's too much glass, it's too much steel, it's too much, concrete. You can reduce this by this, you can reduce this by that, and you can achieve 20% cost saving. That is what a human is going to struggle to do on a day to day, right? So that level of value engineering is something you can be on the lookout for in the future. Evolving roles, talking about evolving roles, a lot of people ask, yeah, I'm wrapping up. A lot of people ask, is AI going to take my job? Well, it's getting more complex. There's no direct answer to that question. But as a designer, you will be expected to be able to code. As a contractor, you're going to be expected to analyze data from information, and collaboration is going to trump specialization. So you're going to have to collaborate with other people. You're going to have to collaborate with other experts. We're going to find out that there are people on our team, on our design team, who do not know how to design, but they know how to code. They can write scripts. They can help push out a concept model from Rhino to Revit, and they're on the design team, and yet they're getting paid for being able to do that. So don't think that you can start just burying your head into design. Design basically will get enabled by other tools. Okay. And lastly, you have to think beyond the tools now. You have to stay future proof in the sense that your ability to solve problems and have foresight will become very important. Professionals that are making data driven decisions will become sought after. They're going to start looking for people who can analyze data, who can look at a series of data and make a call. Say, this is going to help us save 15%. This is going to reduce our workforce by 20%. This is going to optimize our processes by 75%. And those are the people that are going to be taking on these lead roles in the design and construction industry in the nearest future. I hope my presentation has been insightful enough for you guys. It's not a one size fits all whereby you get all the answers to your questions, but I'll tell you to remain curious and inquisitive. And basically, this is the beginning. Thank you all very much, and I appreciate the opportunity to present to you today.
Meet architect Opeyemi Sina-Olulana, who will be speaking on sustainability and construction technology. Architect Opeyemi is a distinguished chartered architect and project management professional with a robust focus on sustainability. As a lead professional and a member of the USGBC lead faculty, he has been instrumental in promoting green building practices. His expertise in systems thinking allows him to provide valuable advisory services on organizational processes and assets, and he integrates agile methodologies into his projects, ensuring efficient and innovative solutions. He holds several certifications, including Project Management, PMP, and PMI Agile Certified Practitioner, PMI ACP. Architect Opeyemi's dedication to mentorship and leadership development is evident in his platform Endless Lessons, designed to inspire emerging leaders and refine their potential.
All right. Good afternoon. It's a good pleasure of mine to be here this session, and I want to appreciate the leadership of Just Design for this opportunity to be back on the platform. I've been given a topic to speak to: sustainability and construction technology. So, into our highlights for the subject of sustainability, slide 2, construction technology, and how this facilitates the subject of sustainability. And then we try to draw a conclusion from all our conversations. I have a very long time, no, let me say short time, to deliver quite a lot of information, but I try to work within the confines of the time given to me. So let's proceed very quickly to slide 5. 5, please. Let's try to define what sustainability is. A lot of us are very familiar with this subject. It's become a topical issue. Sustainability, just some background information, is not about giving up convenience or comfort. It is actually a mandate to redefine what we call quality. It's essentially saying that everything we do today has impact on tomorrow. Projects from design must be tomorrow minded. So let's try to put a definition to sustainability. We can move to the next slide on page 6. Meeting today's needs, talking about food, shelter, energy, and all sorts, without jeopardizing our ability to meet the needs of the future. All right. This is essentially saying that the fact that you need to eat today doesn't mean that you should not eat tomorrow, or that the generations coming behind should have. So that's essentially you know, the cardinal point of sustainability. Key measurements that I'll be speaking to about session together. That's on page 7, please. Energy efficiency, water efficiency, um, and we talk about materials, indoor environmental quality, um, carbon footprint issues, and greenhouse gas emissions issues around site sustainability, and then social economic sustainability issues. Talk, we are trying to set a foundation for our session. Ability is all about construction technology has to play a vision for society. Dr. Alalade made a mention of that uh, essentially in his session. It's a report from McKinsey from 2017, Reinventing Construction, a route to higher productivity. And let's take a look at this very thought-provoking um, statement. Industry is ripe for disruption, and infusing digital technology, advanced automation, and so on can boost productivity by up to 60%. And in doing that, reducing cost by around 20%. This is a major call to action. Some statistics from the make. Next slide, please. We'll be looking at a number of statistics flagged by that report. And like I said before, is a call to action for all of us involved in this industry. Construction labor productivity has grown by only 1%. I'm sure we heard much about that earlier, compared to what has happened around global economy. And now the US example is very scary, that in other sectors have improved by more than 1,500%, right? And what is the implication of closing this productivity gap? We could generate 1.6 trillion, $1.6 trillion annually, and by so doing, we'll be meeting half of the world's infrastructural needs if we're able to close the gap in productivity. A number of solutions were proposed by the McKinsey report, and I want us to take a look at that. I'll be speaking to a couple of them on the next slide. Slide 11, please. Now, let's take a look at the root causes of low productivity and then what are the recommended actions. Now, take a look at low investment in research and development and also digitization, insufficient skills, inadequate design standardization. And amongst the recommended action, we see infuse technology and automation, reskill the workforce, that is, train workers in digital tools, data use, modular construction. And then we need to start rethinking design and engineering, like it's been mentioned, the issue of value engineering. So let's define what construction technology is. On the next slide, construction technology is actually talking about using smart tools, digital systems, better ways of working to plan, build, and manage our buildings in a more efficient way so as to avoid errors and to reduce waste. There are value expectations for construction technology, and this spans from the impact or the benefits we derive from the pre-design to the design, construction, and even the operations and maintenance stage of our building. We find that on the 13th slide. Uh, just setting the record straight in terms of what our expectations should be for engaging construction technology as a driver for entrenching sustainability. All right. Now let's talk about sustainability and its handshake with construction technology. The major goal is efficiency. Page 15. Efficiency is the result when sustainability interacts with technology. If it is not efficient, it cannot be sustainable. If it is not going to be efficient, it cannot be sustainable. Next slide. Sustainable construction, therefore, is no longer a question of if, it is now a question of how, because technology is the key that transforms our intentions to innovations. Technology is the instrument that converts intentions to innovation. So until technology is deployed, our green intentions will remain intentions. And it's important for us to embrace this driver as much as possible. Now, why is this very important? We can take a look at the next slide. Because while the needs are growing, the resources are not expanding. Next slide, please. Sustainability demands that we do more with less. And that's exactly what construction technology enables us to do. So let's look at the areas of intervention for construction technology as a driver of sustainability. I will try to move with some speed now because we have quite a number of things to cover. Now, page 19. It's important for us to start by discussing materials. The European Commission, as is written here, estimates that 70% of product innovation across all industry is derived from new and improved materials. You know, when you talk about the three M's, materials, manpower, and machinery, manpower and machinery will go. If you use an equipment for a project, for example, the highest is you deploy the equipment, it does its work, and it leaves the site. You engage manpower, they do their work, they render their service, and then they are off the site. But the materials will remain with the project occupants. It will remain with the building occupants, and then it's going to have lasting impact on their experience as building users. That's why it is important for us to pay attention to innovation around building materials. I'll give an example here. In 2012, ArcelorMittal launched an organically coated steel that is using eco-friendly pigment, and that achieves 30-year guaranteed durability and does not contain confirmed carcinogen like hexavalent chromium and others. Now you can imagine how much impact innovation is going to have if you are going to pay attention to not just getting our buildings delivered, but ensuring that the environment is preserved and the building users are not only productive, they are also healthy. Page 20. When we solve the problem of material, we have solved 70% of the technical problem and 30% of the cost problem. Let's look at this example of a project in the USA. Now, I'll read it from the third line, the third paragraph. Instead of using just concrete or steel, the building was made with mass timber. And what is the result of this? It helped to speed up construction, reduce waste, and cut down on carbon emissions. So, letting us know that a lot has to do with our building materials. Next page, we'll be talking about carbon negative building components. These are materials that actually pull carbon from the atmosphere. Let's take a look at an example here, Boucher enhanced concrete. And this is concrete mixed with Boucher, a special carbon rich powder made from plant waste. And see what happens. A single cubic meter can lock away up to 25 kg of carbon, far outperforming standard concrete. 25 kg of carbon, you are simply saying that about 28 people will have to exhale, you know, carbon dioxide for a whole day to get 25 kg. And that's what you are locking away by using Boucher. Next is cross-laminated timber. Look at what this does. Each cubic meter stores about 1 ton, while also serving as a reliable load-bearing material. 1 ton is talking about 3 months worth, 3 months worth of carbon dioxide produced by a person. 3 months worth stored away by just 1 cubic meter of CLT. Again, we have algal-based facade panels. Look at what this does. A 200 cubic meter panel setup can capture as much as 25 trees will do in a year. Capture as much as 25 trees, that's approximately maybe 800 kilograms, just by improving our building materials. To take it from page 22, we have examples in Australia, we have examples in Germany. Page 22, please, of a project that was done using coffee voucher. And then see the result. The compressive strength increased by 30%, and the cement usage reduced by up to 10%. Compressive strength increase. These are not proposed projects, and these are not some, you know, uh, live projects, test results that are verifiable. Compressive strength increased by 30%, and the need for cement reduced by 10%. I need to move a little bit faster. Self-healing material. Imagine if our buildings can repair themselves and you don't need workers, no downtime, just site to neat. And I'll talk about a few concrete. Field tests show that buildings using bioconcrete can cut maintenance costs by 20 to 30% compared to regular concrete. 20 to 30%. Don't forget, sustainability is all about that our needs are expanding, and unfortunately, the resources are not directly expanding. So it is important for us to get creative and get innovative to ensure that without the bridge in Rotterdam tested on parts of the Rotterdam Bridge in Netherlands. And after 12 months, engineers saw an 85% drop in visible cracks, despite the heavy traffic and harsh weather. So on the next table and the next page, we've tried to, examine as drivers of change and impact on construction have interacted. And then we're also on the next slide projecting what is going to look like in the next 25 years. This document will be made available to us, so we're able to take a closer look at it. But I just needed to make this information available for all that needs drive innovation and how it has impact on construction. So let's quickly talk about the next area of intervention, which is prefabrication. We must go modular. Prefabrication is a way to speed up our project delivery and in the process also cut costs. See the example of Broad Group China that built a mini sky city in 19 days by moving 90% of the construction to the factory. So what this does is that it reduces waste because you are now building to precision. It lowers emissions. Quality is improved because you are now within a factory controlled. The controlled environment in the factory improves your quality assurance, quality checks, and all that. And then you are able to reuse and even relocate. You can reuse and even relocate. And of course, it guarantees speed. Now, there's a project that was done in Beijing, next page, during the SARS, issue. They needed to respond very quickly. Siatangsha Hospital is a 1,000 bed hospital that was built in 2003. You see, what technology does is that it increases our capacity and speed of response to setbacks. And this actually describes resilience. And resilience, of course, is a life wire, it's a lifeline of sustainability. What did they do here? They used prefabricated buildings to respond to this challenge, and I had 1,000 bed hospital in 7 days. What was the impact of this? Next slide. Now, it says here that during the 51 days of use, it cared for 680 confirmed patients and had only 8 deaths, a death rate of less than 1.2%, the lowest in the world at the time, right? None of the medical workers got infected. This tells you how technology can power our ability to respond quickly to issues, and we need to maximize that. Let's quickly talk about the next area of intervention, which has to do with semi-automated construction equipment. Semi-automated construction equipment, all right. We have moved from manual labor to mechanization. Now it's time to start discussing automation. And then let's take a look at the example of a dozer made by Komatsu in April 2013. How it disrupted the construction landscape. There's something I want to say about the impact of this, and it's on the next page. Okay, let me read this line. Let me read it. This groundbreaking launch marked a turning point in how construction sites operate, bringing in a new era of automation that dramatically enhanced precision, speed, and overall site efficiency. Don't forget, we said if it's not efficient, it cannot be sustainable. Page 30, I will read a quote from the manufacturers of this equipment. Operators report a in productivity. When using this and other technology functions in the IFC machines, operators report a doubling in productivity. And this transfers to the issue of lower maintenance costs, per ton of material moved, as well as better fuel efficiency and therefore reducing emissions. So you can see the impact of semi automation. I'll click the next table. All right. I'm seeing some information from, okay. We try to work with the time left. Okay, this is also a table showing us how we have moved from hand tools up to the stage where we are now discussing robotic bricklayers. Let's talk about Sam on page 33. Sam is a construction robot that works 500% faster than humans. 500% faster than humans. And look at what Zachary Potkamina, the construction manager, had to say. For a lot of different reasons, the construction industry has been slow to adopt innovation and change. And compares a construction site today from a picture of 1 year ago, and with the exception of a few things, it really hasn't changed at all. Now it seems the industry is finally evolving, part of what we are discussing here. And we are trying to bring in a technology, to construction site. Now see the effect. If robots can do the back breaking heavy lifting and leave people to do other jobs, like mental work and all of the complex work, that could work out best for all involved. That was the construction manager of Construction Robotics, the manufacturers or the maker of this equipment. Let's quickly move on to life cycle equipment, and then we try to wrap up our conversation. What you cannot measure, you cannot manage. That's a popular quote from Peter Drucker. And it is important for measurement to be useful, it has to be prompt, because the value of intervention is actually lost once the timing is missed. Therefore, we must be intentional about performance monitoring and smart technology to ensure that our decisions are data driven. I take an example from ScanScore on the next page. They have a couple of life cycle products, and a number of them you can see the impact. Now, look at what it says here. The Interlude platform cut energy consumption by over 40% and then reduce facility management resource need by 8%. Now, they have a sensor made by Sensitech that monitors live compressive strength data. This has reduced traditional cylinder testing by 50%. 50%. And of course, they have AI powered drones that has been responsible for reduction in safety incidents by around 25% on some projects. So technology is the instrument, is the vehicle that sustainability requires to achieve its goals. And there are some other testimony about the products from Scanscore. We can see that on page 36. The ability to monitor concrete's compressive strength in real time not only optimized the construction process, but also contributed to environmental sustainability efforts by reducing waste and emissions. Finally, I'll talk about new construction technologies. A lot has been said, and then we can begin to see that 3D printing, like has been mentioned, is changing how buildings are being made. People are printing buildings now. Yes, you heard that right. People are printing buildings now. Now, Arab did an example and they achieved 75% weight reduction in a particular component and an overall of 40% across the project. We'll find that on the next slide. You see, what this does is not just that it reduces waste or it saves money, it also empowers us to be more creative and to be able to produce complex structures. Next slide, please. I want us to take a look and see these three components here. The last one is the one that was printed by 3D and is going to serve exactly the same purpose as the first two. But here this, the height is approximately half that of one designed by traditional production method, while the direct weight reduction per node is 75%. This means we can save as much as 40% in terms of material requirement overall on a construction project. And there are examples on the next slide. You'll see examples in Highland And then just as recent as July 9 is 2 days ago on the next slide, July 9, Qatar is kicking off the world's largest 3D printed building. This is going to be for schools, the world's largest. This is 2 days ago development. And then you can see how big, 20,000 square meter each. And then you can imagine what this is saying about what the future of construction is going to look like. Now, circular economic solutions, we are also already seeing technologies that are converting old materials to useful ones. Look at what it says on this line. New recycling technologies are turning building waste, go back to that slide, into useful materials. Machines can now crush concrete and separate it so well that 95% of it can be reused. Let's wrap up with the next slide, and then I'll draw a conclusion from all we have been saying. Like I said, this document will be made available to those who are interested. How far should we go to preserve the earth? I came across this news, and this is as recent as some days ago. China built an inflatable dome. In fact, not China built. China is building because they have a couple of places within the country where this is being done. Inflatable dome over construction sites to protect the surrounding area from dust and noise. Covers as much as 20,000 square meters and is good enough to capture 90% of the site dust. It costs as much as $50 million. It tells you how far we need to go to ensure that we preserve the environment. In conclusion, I'll draw a few points for the various stakeholders in the architecture, engineering, and construction industry. The future of construction will not be about concrete and steel. We'll be probing clarity of vision and our courage to integrate for the good of all. For professionals, it is time to speak in both sustainability and technology. The future will favor those who engage early. For students, our education must stretch beyond aesthetics. It must include carbon metrics, systems thinking, and smart tools. Policymakers, the era demands that regulation must catch up with innovation, and we must be ready to support what works. The relevance in the new ROI for investors is sustainable solutions backed by smart tech, that the safest bet for tomorrow. We must encourage a cohesion of all our efforts, and we must charge ourselves to develop a strong future for the environment. I left some frequently asked questions in my slide because I know that there may not be opportunity to answer all of the questions. So there are a couple of frequently asked questions across the various stakeholders. You may want to engage with that when you have the opportunity. Once again, thank you, Just Design, for this platform, and I wish us a very fruitful deliberation at this conference. Thank you.
Welcome to Virtual Reality Construction.
Meet Tomi Olatunbode, who will be speaking on the future of workspaces, tech-infused office design post-2025. Tomi Olatunbode is an interior design expert and the founder of Spazio IDL, an interior design firm that focuses on connecting people to spaces through exceptional design and excellent execution. With over 9 years of experience, she is regarded as Africa's female tech interior designer, as her company, Spazio IDL, located in Lagos, Dubai, and Johannesburg, has delivered exceptional spaces for some of the most recognized firms, including Ernst & Young, EY, Paystack, 4 Points by Sheraton, Casio, Paystack, Monipoint, Cuda, amongst others. Tomi holds a Master of Interior Design degree from Florence Design Academy, Italy, as well as a bachelor's degree in computer science from Covenant University. Before founding Spazio IDL,
Hi everyone. Good day, because I think we're all in different time zones, so I'll just use the word good day. It's great to be here and to hear from the amazing speakers early on. Thank you, Dr. Alalade, Dr. Hassan, and Architect Opeyemi for the insightful session. Today I'll be taking us through the future of workspaces, tech-infused office design post 2025. But before I start, I'll just do a little bit of introduction. So I'm Tomi Olatunbode, Creative Director of Spazio Ideali. No, I'm not an architect. Spazio Ideali is a full-service, multidisciplinary interior design firm that provides exceptional workspaces or spaces for our clients. We connect people to spaces through creative design, experiential spaces, and excellent execution. We've worked with a varied number of clients, such as International Finance Corporation, IFC, a member of the World Bank Group, African Development Bank Group, helping them design the interior of their Cape Verde Tech Park project. That's the largest tech park in West Africa, located in Cape Verde. We've also worked with 4 Points by Sheraton, Ernst & Young, and then some popular companies you might know, such as Paystack, Cuda, Monipoint, and the rest. We have a diverse team of exceptional talent within the organization, from architects to interior designers, builders, project managers, civil engineers, etc. Personally, I like to say that my mantra is I believe that design is problem solving. So I do hope that this session is insightful for everyone. And for those who are interested in going into interior design, just interested in how workspaces are going to evolve over time, I hope you find this quite insightful. So let's get into it. The future of workspaces, tech-infused office design post 2025. We already all know how workspace has changed over the years, especially post-pandemic, post-COVID, for example, how we are now more in tune into the hybrid workspace. And I remember talking about that a lot during COVID. And that's because, at least from an organization standpoint, we had already started implementing hybrid work for way before the pandemic. And it's good to see people now doing that much more often. But that was then. Now, looking into the future, with hybrid work being quite the norm now, how is workspace going to evolve? And what can we do? How can we position ourselves as interior designers or architects to ensure that we're moving along with the times and ensuring that we're at least delivering spaces that meet the current expectation? So first of all, I have divided because first the future of workspaces is large. We can talk about it from now to tomorrow. So what I've done, based on what the organizers have requested for, is to break it into 4 distinct areas, into 4 zones. So second slide. And I'll be talking about those 4 focus areas in terms of the future, because when it comes to man's imagination, the future can be limitless and endless, but let's just focus on these 4. So the 4 will be collaborative, tech and adaptive environments, space planning using occupancy and interaction data, designing for neurodiversity using sensory and lighting tech, and then tech-enabled acoustic and visual zoning. So I'll start with the first one, and then we would move to the fourth one. I'll try and make it short and insightful for everyone. Um, so collaborative tech. Why is collaboration important? I think everyone knows why it is important and how over time we've seen how organizations have been able to grow using collaboration. Um, if you're building an organization, for example, like I'm an entrepreneur and you're building a global team, for example, you'll be having people work in different areas. Or even if you're localized, for example, you can have people on site and maybe you're somewhere else, and you want to work collaboratively and ensure that you're still delivering excellently to your client, or still delivering. Um, or even if it's just within the office, aside from the work that I do, teams that are working in different areas or different functions or different locations. Collaboration and collaborative tools that we have do help in ensuring that there is excellent delivery. So I'll use Patio Ideally, for example, as an example. I'm based in Singapore and it's Saturday, yes, Saturday morning, it's past midnight. And I have a team in Lagos, for example, that they are working in Lagos, but I'm based somewhere else, and we can work collaboratively and still ensure that we deliver seamlessly. Even the team that sits in Lagos, there are teams in Lagos, there are members of our teams in Abuja, members of our teams in Dubai, but everyone can still work collaboratively to ensure that we still deliver excellently to the client, regardless of where the client is. For example, for the projects we did for Cape Verde, for the AFDB at Cape Verde, right, that was majority of the design was done remotely. We didn't have to go down to Cape Verde to do all of the details and all of the design. All of that was done because of the tools that we now have available to us. And there are some that are quite popular, which I would mention before I go to the more nuanced ones, or the newer ones that we probably are not aware of. The first would be Zoom, for example, or Google Meet. I think everyone during the pandemic got to use or know Zoom, and it's been something that we now use to collaborate. But aside that, for organizations, there are workspaces where you can collaborate together. So, for example, Google Workspace, or Teams, Microsoft Teams, for example, where even down in terms of working together, teams can work on a document together. I'll give an example. This presentation that I'm doing, I wasn't the only one who worked on it. There was more than one person that worked on this presentation, and we're in different time zones, different locations, working on the same thing at the same time. And that's what collaboration helps, or the tools that we have now for collaboration. For Spatio, for example, we are able to work seamlessly together, even though people sit in different locations, in different countries, in different time zones, using tools like Slack, for example, or Google Docs, Google Sheets, etc., to work together. Aside that, for creatives, Miro is something you might want to consider because it's a whiteboard or white space where you can collaborate easily. In terms of the future, and this is what is common, right? But we are seeing more advances, for example, in even meeting translation. So, for example, say you have a client that sits, or a staff or an employee that sits in Paris, for example, and they speak French. You can have a meeting where now we do have our meeting tools evolving to be able to translate in real time, right? So that they can break that communication barrier between people and improve collaboration. But that's what we all know now. Now, going to the future, what are the collaborative tools accessible to us, and what are adaptive environments? So, in terms of other collaborative tools that are being accessible, right? Facebook, that's Meta, is working on a new tool called Orion. Although they've done a prototype, it's still not out there, but it helps bridge the gap in terms of distance between team members. So, for example, even though we are not sitting in the same place, right? It's good that we have the collaborative tech such as Slack for us to work together. But then there's still some distance that there's still some part where the distance cannot, when it comes to connection, where the distance cannot bridge. And with devices such as Orion, for example, which uses augmented reality, you can bridge that gap in terms of interacting better with your team members, or within an office space. Um, Now, adaptive spaces and how it links to collaborative tech. First of all, what are adaptive spaces? Why is it even important in the first place? So I'm sure we know, well, I do expect that we know what adaptive spaces are, but just if we don't, I will just give an example. So, an adaptive space is a space that can be utilized in various forms and ways um, to ensure that you have fluidity in its use of space. So an example would be in an office space, you have a space that is designated. Typically, what we have currently for most spaces, you have designated work zones or designated zones. So you have maybe a work zone, a lounge zone, a play zone, a quiet zone, etc. But with adaptive spaces, you have a space that can function or can be fluid and can function as multiple zones at the same time. The advantage of that is that it reduces the amount of square meter or the amount of space you need to use as an organization, because you can reduce or you can use one space in terms of multiple uses. Um, and why is it important? Like I said, reduces your cost overall. It also helps in terms of sustainability. Um, in terms of adaptive spaces, so you have a space that is a lounge, but then you can convert it to a meeting room or you can convert it to a workstation, for example. How does that work? And how is that the future? Because it is the future, right? Um, one way it can work, for example, is in the the furniture and in the adaptability of the space. Now, we all know that AI is becoming quite prevalent, and when it comes to workspaces or design, there is a lot that AI can use and the amount of use cases it can use. So, for example, a space can be knowledgeable enough to be adaptive. An example is based on, say, your scheduling or your meeting calendar, right? This is space A. And usually for most offices now, you can book a space. Based on your booking system, right? Space A has been booked for a meeting room for 9 a.m. to 10, and then someone wants to use it as a collaborative space from 10 to 11 for brainstorming sessions, etc. The space understanding what they use for can then adapt just prior before the use of the space. And you can adapt in areas such as ensuring that the desk and furniture, that's modular furnitures, are moved and rearranged using robot bases, for example, or even adapt in terms of lighting. So, for example, the lighting type you need for a meeting room is different from a lighting type you would probably need for a presentation or a focused workspace or for collaboration, etc. And then you can have all of those things in terms of a space, knowing that based on this time zone, I need to change and adapt. I need to change the lightning, um, um, the lighting, for example. I need to change the ambience. I need to change the Kelvin of the light. I need to change also even down to the HVAC. That's the amount of air, that's air control. So, for example, if the space is being used for 6 people, right, what's the amount of airflow you need compared to a space that you have 20 people, right? The space can adapt to those changes without you having to zone spaces and then use more space because you're trying to do separate work. Um, One very important thing in terms of adaptive environments that we are seeing, right, is sensor driven spaces. So I'm going to use the project we did for IFC, for example. That's the World Bank Group in the redesign of their space. And one of the things we did, for example, was ensure that, at least based on what the client's brief was, to ensure that the space was sensor driven. So, and this is quite something that everyone, at least I think, can adapt in terms of ensuring that your space is super adaptive. So the space only comes alive, the world become alive when someone enters, right? And then the space senses if someone is there, and then the light comes on, the AC comes on, HVAC comes on, etc. And when someone leaves, right, the space go off. The good thing about things like that, so adaptive spaces, adaptive environment, is that first of all, you conserve energy, which speaks to what Axel Ope talks about in terms of sustainability, right? Um, and then you also ensure that I think also Dr. Hassan talked about that briefly when you talk about facility management, where you 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 totally ensure that your optimizing the use of the space, right? And not just wasting resources based on the space. So aside from sensor-driven spaces that affect light and HVAC, there is also sensor-driven spaces that also affect simple things like smart blinds and window blinds. There was a client I remember that we had who had a concern with one of their training rooms, and he had like a full-on glass ceiling, and the glass ceiling was always ensuring it was coming into the space, right? One of the propositions that we suggested to them was to use sensor tinted window films. And what that would do, for example, is when the sun is very hot, right, the sensor films actually come in place, right? And because of the tint, reduce the amount of heat that comes into the space at that point, and ensuring that the cooling that they have within the space is optimal. And when, for example, there isn't a lot of sun, for example, the tint also just goes back, right? And then you can have or see, or the glass ceiling is the way they want it to look, where you can actually see the sky, etc. And those are things that, in terms of adaptive environment, aside from that, you also have smart blinds. And I think this for me is like one of the things that I've seen a lot of people use it in homes, right? But we're just tending to use that in offices. And so now for smart blinds, right, what a lot of people are aware of is, okay, you use an automated blind, you use your phone, and then you say, okay, blind open, and then blind open, and then you say blind close, and then blind closes. But there are now more technology that you can use in terms of creating spaces that are adaptive in terms of even things like blinds in the office, right? And how it affects the use of space. So apart from user flow, which you can use, or your use case where you say, okay, at 9 a.m. I want my blinds to open, and then at 6 p.m. I want my blinds to close, right? There are blinds now that are focused on light intensity. So what's the amount of heat being emitted outside? And then that'll determine whether the blinds go up or go down, or natural light optimization, or location relativity. And for location relativity, what happens is that it is already pre-programmed right into the app, where based on the location of your building and its interaction with sunrise and sunset, right, your blinds are optimized to ensure that they come up at the right time, they close at the right time, etc. Moving on to the second section, which is space plan using occupancy and interaction data. Um, I think Dr. Hassan also spoke on this, where data is actually the new gold, but then how can we use data to optimize design? So there are few organizations that have started using these ideas, right, as use cases, and I'll mention them at the end or I can mention them now. So you have Deloitte Amsterdam, for example, Microsoft Redmond, and Accenture in Madrid, where they've used some of this use cases and are seeing the positive use. So for example, Accenture uses occupancy data to ensure that their spaces are optimized, and these are things that we can actually integrate into the workspaces that we design to ensure that they are properly used. So, for example, for occupancy data and interaction, and I'll use this focus area 2 to link focus area 3 and 4 because they're sort of integrated, right? So, for example, in Accenture, right, they use data in terms of how many people are going into the restroom for us to know how many people actually, how often we need to clean the restroom. And you can ask, well, how do they know? For example, it's sensors. So you open the door, they know, okay, the door has been opened 5 times or 10 times. So the amount of usages of this space is like this, etc. Same thing with even just the office space, right? And then sensors the data you can get from the sensors you install or implement in your design can tell you what spaces do employees use the most, for example. And based on that, you know, okay, employees love using this kind of space. So do we want to ensure that we can mimic these zones where they love working across board so that we can ensure that our employees are efficient? Or what's the number of people in a space? And based on the occupancy of people in a space, right, you can adjust temperature. You don't need to go manually and then adjust temperature. Just based on the number of people that walk into a space, a lot of people that check into a space either through their cards or through their Face ID or through their app, whatever it is. Okay, I need to adjust the temperature. The space knows it needs to adjust the temperature. Also affect air quality, water, recycling, all of that. Moving down to designing for neurodiversity using sensory enlightenment tech, it's same thing. Now, I'm sure we understand what neurodiversity is or what neurodivergence is, but even aside that, right, aside from those that have either ADHD or are autistic, right, spaces can be optimized for its users' need, and it's not just creating or designing spaces and for the user, but for actually the user. Give an example. Imagine you go into a quiet work pod, right? Just because you checked into a quiet work pod, the work pod knows that, the light needs to be adjusted to a particular Kelvin because that's the best way you work. The noise needs to be at a particular level. So it's either it's doing noise cancellation or it's doing either a sound masking system, etc., right? Or just affecting sound and airflow, or that, you prefer your best work is at this certain temperature, etc., right? Spaces are now getting smart enough with the use of AI to be in tune to the user of the space. So it's not just for the employees or just for everyone, it's for a particular person at a particular time in a particular space. And that can be done across board, not just for particular users, but also for those that have neurodiversity and are neurodivergent. Same thing with acoustic zoning, because I also talked about you enter, for example, a work pod, and then the sound is exactly the way you prefer to work. Some people can work in noisy spaces. I can work in a noisy space, for example. Some people like quiet spaces. Some people like music, etc., etc., etc. But spaces are designed now to work in tandem with user preferences, right? So sort of like space manipulation in terms of this is how I like to work. So if I enter this work zone, the workspace is designed for me. If I leave, it goes back to the normal setting. If someone else comes in, it's designed for that person. But that's basically it in terms of what we see post 2025. I hope it's not a lot, but it's what we are seeing. In conclusion, what I see is that spaces or office design will be designed for three things: flexibility, inclusivity, and dynamism, ensuring that employees are productive and ensuring that people do their best work and be their best self. And that's, to be honest, what life is about. And that's what we do as designers, right? Our work is to ensure that people are productive. And when people are productive and their best selves, they'll deliver the best for the organization. And when they deliver the best for an organization, the organization itself delivers the best work that they can do. And in turn, every single person is happy. The society is better for it. The employees are better for it, right? Everyone is better for it. And everyone is well, right? Especially when it comes to wellness. So ensuring that spaces are in tuned to the user promotes wellness and in turn basically ensures, apart from the environment and sustainability overall, right, every single person is their best self and can deliver optimally across board. Thank you.
Welcome to Virtual Reality Construction Lab. We leverage long-term effectiveness of gaming as a training strategy in education. The lab features realistic embodied experiences in a totally safe environment that mimics real-world operations. We evaluate learning behavior and strategies of learners while adapting to the new virtual construction lab. There are full audio and visual features that engage users' senses. Players have a fun yet challenging training in construction assembly split into many levels of difficulty. They learn object recognition, matching, memory, body movement, fine motor learning, cognitive and physical skills. There are full audio and visual features that engage the human senses. Equipment manipulation is simplified and enabled based on level objectives. This study recommends best game development workflows and decision-making strategies for educational institution and industry adoption. Welcome to the future of practical construction education.
Meet Samuel Afolabi, who will be speaking on cybersecurity in architecture, engineering, and construction. Samuel is a cybersecurity professional with a professional journey spanning managed security service providers, MSSPs, fintech, edtech, e-commerce, insurance, govtech, and IT consulting. He brings a wealth of experience across diverse industries. His extensive background in information technology, including software engineering, low-code, computer networking, data center management, SOC/NOC management, and cloud computing, enables him to ethically hack and securely design technology infrastructures. He holds professional certifications from esteemed organizations, including Amazon, CompTIA, EC Council, Fortinet, GitHub, and Microsoft.
All right. Good morning or afternoon from wherever you're watching from. Well, I'm based in Abuja, Nigeria, so it's afternoon over here. All right. Once again, my name is Samuel Afolabi. I am a principal cybersecurity consultant. All right. In the cybersecurity industry, they call me Lord Sam. So yeah, feel free to call me that. I'm not an architect, okay, even though I feel a lot of pressure when everybody is talking about construction and architecture. And I decided, you know what, maybe I should jump into the construction industry and all of that. But yeah, it's been an awesome session so far. All right. Today we are diving into a critical topic. All right, that's reshaping how we think about construction security. Okay. The previous slide, please. The next. The next. Okay, great. Thank you. Before we begin, I want to share a quote that perfectly, captures the urgency of our discussion today, which is time is what determines security. With enough time, nothing is unhackable. All right. This quote from ATE, that's Hanieki Tochukwu Ezekiel, reminds us that cybersecurity isn't just about building walls; it's about building resilience and also staying ahead of evolving cyber threats. All right. The agenda for today. All right. We will explore some key areas. First, we will examine the digital transformation happening in construction right now, which I believe like the last two, three speakers have touched, so I won't dwell on it for a long time. And the second thing is we'll dive deep into the cyber threats landscape, specifically targeting construction. All right. Third, we'll discuss, all right, practical security frameworks and best practices you can, implement. And lastly, we'll look at a way of future proofing strategies to stay ahead of emerging threats. Now, each section builds on the previous one. So by the end, you will have a comprehensive understanding of both the challenges and solution in securing smart construction environments. All right. So yeah, let's start with the numbers, okay, that tell the story of this transformation. Okay. We are looking at a construction tech market that projected, you know, that's projected to reach $12.7 billion by 2027. All right. That's not just growth, that's explosive transformation. Okay. By 2025, 85% of construction firms will be using IoT devices. All right. And it's happening already. We're going to look at some case studies as well. Think about it for a moment. All right. In just a few years, the vast majority of construction projects will be digitally connected. But here's the sobering reality. Um, Alongside the digital revolution, okay, the previous slides, please. Thank you. Alongside, the digital revolution, okay, we've seen 156% increase in construction cyber attacks. All right, and that's in 2023 alone. All right, we've seen a 156%, all right, increase in construction cyber attacks. And the average cost of a data breach has reached $13 million. All right. Now, these aren't just statistics, they represent real projects delayed, real companies damaged, and real people affected as well. Okay. And the real, key drivers behind this transformation are fascinating and powerful. All right. One of them is smart buildings. All right. We are not just constructing smart buildings anymore. We're not just constructing buildings anymore. We are creating intelligent environments that can adapt, learn, and optimize themselves. Now, these buildings have sensors that monitor everything from air quality to energy usage to structural, integrity and occupancy patterns. Okay. The next, key driver is connected equipment. All right. Today's construction sites feature equipment that talks to each other. All right. Cranes that coordinate with delivery trucks, um, excavators that report their fuel levels, all right, and maintenance needs in real time, and also safety equipment that can automatically alert supervisors or facility managers, to potential hazards. All right, these are one of the key drivers. Another one is powered automation, where we have artificial intelligence, all right, optimizing everything from material ordering to scheduling, predicting maintenance needs, and even identifying safety risks before they become, incidents. Another one is real-time monitoring, whereby, project managers can now oversee multiple sites simultaneously through dashboards, all right, that provides instant updates on progress, resource allocation, potential issues. This level of visibility was unimaginably, like, just a decade ago or more. All right. We also have a key driver of remote project management. All right. Especially accelerated by, it's accelerated by recent global events. The ability to manage construction projects remotely has become not just convenient but essential. Teams can collaborate across, continents, and I believe the previous speaker did justice to that. All right. Inspection of sites can happen virtually. Decision can be made in real time regardless of, the physical, location. Next slide, please. Now, what are smart construction sites? Okay. Think of them as interconnected ecosystems where every component, from the workers hard art to the concrete mixer to the site security system, all right, all connected and communicating. These sites use sensors to monitor environment conditions, ensuring optimal concrete curing or alerting you of dangerous weather conditions. All right, where you have workers wearing technologies to track their safety and also their location in the building. Okay, where you utilize drones for site surveys and progress monitoring. Okay, now the beauty of smart construction sites is their ability to predict and prevent problems before they occur. A sensor might detect that a piece of equipment is showing signs of wear before it fails. All right, signs that okay, this device is about to go bad. Okay, it gives you that heads up. Okay, maybe weather sensors that can automatically adjust concrete pouring schedules, or safety systems that can detect when workers enter hazardous areas and provide what's it called, immediate alerts. Okay, now this is like a high level overview of what smart construction sites are. Think of them as interconnected ecosystems where every components, all right, are connected and also communicating. Next slide, please. Now, smart construction sites, we have IoT sensors, HVAC systems that are intelligent. All right, take for instance the air conditioner in my house. Okay, I control it with my phone. I regulate it with my phone. Even if I'm not at home, wherever I am in the world, I can control my HVAC systems. Okay, security systems. I mean, I work in the cybersecurity space. Of course, I'll have CCTV cameras in my house. Okay, um, IoT sensors. I mean, I'd say 30% of my house is powered with IoT. Okay, these are smart construction. Okay, and bringing it now, these are smart. This is a smart home, description from my own hand. But when we now talk about smart construction, where the smart construction sites leverage connected sensors, AI powered machinery, drones, and wearable devices to basically improve efficiency and safety. All right. These sites, all right, collect a massive amount of data from equipment performance to worker health metrics, all which needs to be protected from cyber threats. Next slide, please. Now, we want to look at the rising cyber threats in the AEC industry, how you as construction engineers, architects, project managers, and so on, how you can protect yourself. All right. Now that we understand the digital transformation, let's examine the dark side of this revolution. Okay, there is a dark side to it. The construction industry faces unique cybersecurity challenges. That's or should I say the AEC industry? Okay, faces unique cybersecurity challenges that many other sectors don't encounter. Okay. Number one is ransomware. From the word ransom, okay, if someone is being kidnapped, okay, ransom is demanded, and there's a possibility that when you pay the ransom, the person is not released or the person is, eliminated. Now, same flow for ransomware attacks. Okay. It's the most devastating threat facing, the hazy, industry and particularly construction companies today. Ransomware doesn't just encrypt your data, it shuts down, entire operations. Imagine a construction site where all the smart systems suddenly become inaccessible. All right. Um, Safety, what's it called? Safety systems fail, project timelines become meaningless. Okay, that's what ransomware can do to a construction site. We can see phishing and social engineering. All right, we can see IoT devices being exploited. All right, we also have insider threats whereby employees are or workers are accidentally or knowingly leaking information. All right. We also have data breaches exposing sensitive personal and project information. All right. These are the common, cyber threats in the construction industry. Next slide, please. Now, what are the impacts? Okay. Number one is project delays. Okay, when systems are compromised, work doesn't just slow down, it often stops completely. All right. Number two is loss of intellectual property and client trust. All right. Architectural designs, engineering innovations, proprietary construction methods. All right. They represent years of investment and competitive advantage. Now, when these intellectual properties are stolen, all right, a company will not just lose, the current project, but also future opportunities. All right, we look at financial losses when you have to pay ransom from what I mentioned earlier regarding ransomware attacks. Okay, you also face compliance, regulatory fines. Okay, in Nigeria we have NDPR, that's Nigeria Data Protection Regulation, and there's a fine if you encounter a data breach. It's either 10 million naira, all right, or 2% of your annual gross as a company. Okay, next slide, please. Now, why is construction vulnerable? Okay. Legacy systems integration. Many construction companies are trying to integrate decades old systems with cutting edge technology. Now, these legacy systems were not designed with cybersecurity in mind. All right. They often lack basic security features and can create vulnerabilities when connected to modern networks. Okay. Legacy systems, rapid deployment. So construction projects, all right, sometimes operate under tight deadlines or timelines or even tight budgets. Okay, security considerations often take a backseat, all right, to get systems operational quickly. Okay, multiple stakeholders, all right, high value intellectual property and sensitive data, all right, extended supply chain vulnerabilities. Okay, these are like these are the components that makes construction, all right, really vulnerable. Okay, next slide, please. Now let's look at real world cyber attack cases. Okay, next slide, please. All right. First one is bird construction. All right, based in Canada. All right. This case study demonstrates how quickly a ransomware can escalate. Okay, a particular ransomware group, that's a group of hackers, they encrypted the entire 60 gig of data and demanded $9 million from Bird Construction. All right. When Bird Construction refused to pay that amount, the hackers rather, they leaked the data publicly. Now, this wasn't just about money; it was about reputation and client trust. Okay. The operational impact of this, all right, affected multiple ongoing projects. The next, case study we will look at. Okay. Next. Now it's Bouygues Construction based in France. All right, the same hacker group, okay, affected them and also shut down their operations. Okay, 200 gig of data was stolen, and the hackers demanded 10 million, I think 10 million euros or so. Yes. Okay. The company chose not to pay, but the operational disruption was significant. It was really significant. Let's look at the third one. I think it's Interserve. Next slide, please. Next slide. Yes, Interserve in the UK. All right. 100,000 employee records were stolen. Okay, that's huge. Next slide, please. Next slide. Looking at Skenda construction in the United States, all right, this case shows that sometimes preparation pays off. Okay, while this attack affected 1,067 individuals, okay, the company's robust backup system saved them a bunch as well. Like it saved them. However, 1,067 people were affected. Okay, as a result of this ransomware attack that affected Skenda construction. Next slide, please. There's a particular construction company. I'm not allowed to disclose their name because it's a company I work with closely. All right. It was a phishing attack that led to to BIM and project data, or their BIM and project data was stolen. All right. Now there was a theft of architectural plans, client data, and project timeline. Like sensitive information was stolen as well. All right. Next slide. All right. Basically, we are looking at case studies. Okay. I feel like sometimes when as cybersecurity professionals we talk about these things, some organizations feels like who is hacking us? What are they trying to steal? But by looking at case studies, okay, you learn lessons and you build resilience from there. Colonial pipeline, okay, a ransomware attack, affected their operational technology systems. $4.4 million was demanded as a ransom. Okay, that was what happened to Colonial Pipeline. Next slide, please. Next slide. Old smart water treatment as well. Same thing. All right. Next slide, please. Data privacy concerns. Okay. Now, let's examine the types of sensitive data that smart construction sites collects and why protecting this data is crucial. The first one is personal data. Okay, most construction sites collects an unprecedented amount of personal information from worker biometrics for access control, location tracking for safety purposes, health monitoring through wearable devices like the one I'm wearing right now. All right, and detailed employee records. Now, this data is incredibly sensitive and is protected by various privacy regulations. The second data is financial data. The third one is intellectual property, client data, security data like access logs, surveillance footage, all right, security credentials. And we also have, operational data as well, equipment performance data, maintenance schedules, safety incident reports, all right, that provide insight into operational efficiency. Okay, client data like customer information, project specifications, confidential requirements. All right, these are sensitive informations, okay, that are being collected in the AEC industry. Now, let's look at the regulatory compliance that are guiding this data collection. Okay, next slide, please. GDPR in Europe, all right, that's General Data Protection Regulation. They hold it very dearly. Okay, you breach this regulation, the company is going to be sued. The construction company will be sued. The project management company will be sued. All right, and I mentioned earlier that in Nigeria we have NDPR, that's Nigeria Data Protection Regulation. If you experience or if you have a data breach, the fine and the penalty is 2% of your annual gross as a company or 10 million naira, whichever is higher. That is what the regulator is going to fine you. In California, United States, we have the CCPA, or that's the California Consumer Privacy Act. It grants consumer rights over their personal data. All right. We're also looking at industry standards that are providing frameworks for information security management. The ISO 27001 is there. The NIST framework is there. You can apply it in your in your firms, in your companies. All right. The SOC 2 is also there. HOSP, all right, it's also there. Now, understanding and complying with these regulations isn't just about avoiding fines. No, you're not trying to avoid penalties. It's about building trusts with your clients and also, stakeholders. Now, finally, let's look at the best practices on building resilience. All right, building cyber resilience when it comes to construction projects. We've looked at the digital transformation of smart construction. We've looked at different type of cyber threats affecting construction sites. We've looked at the impact. We've looked at case studies, all right, of construction companies that have been affected with cyber attacks. Now let's look at how you can build a solid cyber resilience. One is adopting security by design. Okay. Now, this means from the very beginning of your project, all right, that's from the from the planning phase, not as an afterthought. You incorporate and integrate security measures. Okay, involve cybersecurity experts from the initial planning stage. Okay, they can help you identify potential loopholes, potential weaknesses before the IoT systems or the technology systems are deployed. All right, they make sure that security controls are built into the architecture. All right, that's the first one. Second slide, please, or the next slide rather. Securing of your IoT and connected devices. Okay, I mean, just towards the end of last year, the MD of a real estate company reached out to me and my team. All right, just built these, mini estates that is like, I think 80% technology powered. All right, down to the gate opening the estate. There's a CCTV camera capturing the plate number of the residence that opens the gate for you. So you literally don't have much security guards. You can't go in if your plate number is not captured in the system. So most of the IoT devices that were, purchased, we changed their default passwords. We made sure the firmwares were updated. All right, we disabled unnecessary, device features. We implemented device authentication as well. We encrypted the devices as well. So please, when you're purchasing these IoT systems, it's important, you ensure that they are well secured, all right, and they are well protected. Okay, next slide, please. Data encryption and privacy protection. I mentioned GDPR. We have CCPA. We have NDPR. Wherever country you are residing, I'm sure there is a cybersecurity or data privacy regulation in that country. Leverage the regulatory framework, all right, to build security into the smart constructions you are doing. Okay, that will basically save you a bunch from regulatory fines, from you breaching client trust. This will save you a bunch. Next slide, please. Other critical recommendation, user awareness and trainings, vendor and supply chain security. Okay. I mean, a lot of times you have vendors that supply things for you. Supply chain is basically, you have vendors, you have third parties that supplies these devices, these smart devices for you. Okay. You need to assess them. There's something we call vendor risk assessment. You need to assess your vendor to be sure that the vendor is providing the rights and the most secure gadgets for you. Okay, user awareness and training. The human element of security is often the weakest link. So it's important you provide, regular trainings, security trainings to your, workers, to your employees. You make security awareness a part of of safety culture. All right, that already exists in the construction sites. All right, somebody going to this construction sites, you ask the person to wear a helmet, you wear this, you wear that. Make cybersecurity awareness part of the safety culture as well. Okay, regular assessments. I gave you a scenario. A real estate company that just built a mini estate reached out, and the purpose was to make sure that we, as cybersecurity experts, all right, we assess the security of all the devices that were purchased, from the smart smoke detectors, all right, smart refrigerators, smart water heaters, smart, like everything in the house was literally smart. So regular assessments of the security, all right, in these devices are, very, very important. Okay, next slide, please. And I will round up with that. Securing smart cities, smart offices, smart homes, smart estates, and, buildings requires a holistic approach that combines technology, processes, and people. Now, this right up here, okay, encapsulates the key to successful cybersecurity in construction. Technology alone cannot solve the problem. It requires a comprehensive approach that addresses all aspects of the challenge. As we look into the future, several trends will shape the construction security, like artificial intelligence, quantum computing, 5G, or I think 5G is here already. I think 6G, 7G. All right, these innovations, they are here to stay. All right. However, they require, a comprehensive approach. All right. Just so to make sure that your construction sites are secure, the smart homes and smart offices you are building, you are designing, they are secure. All right. Cybersecurity is not just about data, information, privacy. It's about lives and properties as well. All right. Just to wrap up, okay, still, giving the case study of, the project I worked on last year, a mini estate that was built. We were invited to basically do what we call ethical hacking of the estate. We basically started tampering with the, refrigerator, the smoke detectors, the water heater. Like we some of my guys basically went to the water heater and made sure the water heater was only, disposing, what's it called, discharging hot water only instead of cold water. All right, the refrigerator, sending excessive current to heat, whereby it started, shocking people. You want to touch your refrigerator in your own house, it is shocking you up. All right. So security is not just about privacy. It's not just about, data or information. It's about, lives and property. The key to future proofing is building adaptive, resilient systems that can evolve with emerging trends, and technologies. This requires ongoing investments in security capabilities, continuous learning, and a culture that prioritizes security. Thank you very much.
Meet engineer Hani Serhan. Engineer Hani brings over 32 years of experience in electromechanical building services. He has contributed to a wide range of projects including hospitals, hotels, factories, residential, and commercial developments across the Middle East, UK, and Nigeria, working with top MEP contractors and consultants. Engineer Hani combines his technical background with a strong interest in ICT, developing custom productivity tools using Microsoft Access to enhance project efficiency, record accuracy, and future cost estimation. He also has a strong interest in practical, results-driven approaches to project scheduling and resource allocation, favoring real-world solutions over purely theoretical models.
Good evening, everyone. My name is Hani. I'm a mechanical engineer by profession. I'll be speaking briefly about 4 topics: the BMS optimization, HVAC, smart system for energy optimization, renewable energy integration, namely solar power, and the last topic is about energy modeling. So I'm going to use a practical approach, like similar to most engineers, more than critical thinking approach. So I'll start with the first topic about the BMS optimization. And like we know that BMS is a computer-based control system. Sorry. Sorry, just am I audible? All right. So in a BMS system, like it is hard to imagine at recent time to have a sustainable building without having an integrated BMS system to it. And that will enable managing and monitoring the electromechanical services, including the HV system, the lighting control, the also ELV system. So the main goals of the BMS in modern building for energy optimization is to centralize control of equipment and machines and to monitor them in order to optimize energy usage and also to get real-time data and reporting. Now, in this picture, it's simplification for what is like we usually install on buildings 50, 60 years ago, if not older. But at that time, it was impossible like to have a central command or workstation to control and to monitor all the equipment on the building and the lighting, and also the electrical panels where we can energize multiple sources from it. So now, like in the last 20 years, this technology become affordable, the building management system. And we can see that the integrated building system, like, will have multiple integration to it, can have the HVAC system, the lighting system, also the security integration. Now, in this diagram also we can see that the elevator is monitored and controlled as well by the BM system, fire alarm and the security, the CCTV, and energy management. Energy management, like for example, water meter or BTU meter. BTU meter is to measure the cooling energy, for example, for multiple zones. So if something shoot up like out of normal, it can be like spotted straight, there's a problem there, and act on it to rectify the problem. Also, the lighting integration to the BMS system, so which like will automate the energy usage by scheduling the time or connecting the lighting system, like the external lighting, to some sensors, like will automatically will sense the illumination from the sun and can switch on and off automatically. So here it just like the levels we have for BMS systems. So the easiest one is the top one, which is the workstation, where the computer of the BMS will have the operator will monitor and also control, change the parameters of the system. On site, there's the automation level, and there are two types of field levels. One are the sensors and detectors on the left-hand side, and the controlling devices on the right-hand side. So on the left will enable us to monitor the system. On the right-hand side will enable us to control the system. So for example, to control the cooling capacity, to control when we will have cooling, when we'll switch off cooling. This can be applied to a zone of rooms or individual rooms. So here the key components of the BMS system, the sensors, controllers, communication network. And this is a graphical interface, how the BMS usually look like. And like it shows that we can have control over all the components of the system and equipment. And we can also automate the parameters such that if something shoot out of normal, we will have alert message, so the maintenance team can act on it immediately. Also, we can extract a lot of data from it about the energy consumption and like across the year, and from it we can analyze those data and find out how we can optimize on the system. For example, the electricity usually at peak time is very expensive. So one of the things the BMS system can help us is to monitor the consumption at peak time, and it can be automated such that it will divert to, let's say, solar power energy or inverters with battery, so to be off the grid at the peak time, so to reduce the bill of the main utility. Here is a more zoomed in a graphical interface. It's about an AHU, and it shows how we can like zoom in to micro monitor and manage our equipment of the HV system. Now, the key function of BMS is, as obvious, it's monitoring and controlling the system and to automate it. And most important, or one of the most important features is for the energy management, like getting energy meters information, getting the consumption, and analyzing those information, and based on it, find a way to or ways to optimize on energy consumption. Also fault detection, and of course, data collection and reporting. Now, the BMS system is nearly used for all systems, all building types of buildings. Now, residential are a bit because of budget, like not like most, they don't go for it. But modern residential buildings, they go for building for BMS, though they tend more to go to home automation. Now, a feature of the BMS, like we monitoring and control, automation, energy management, fault detection, and data collection and reporting. Benefit of building management system: improved energy efficiency and reduce operational costs. For example, let's say we have a like event and we need to switch on the EC. So what we can do is to do this from the BMS system rather than sending an attendant to switch multiple thermostat to switch on all equipment, the EC equipment. So it can just be done from the BMS system with a single click. And the same when switching off. So when the event is over, also by a single click, we can achieve this. So that is an example of reducing operational costs. Now, enhancing occupant comfort. Like one of the advantages of BMS system, like it can get to a lot of sophisticated controlling precision, much more than the normal thermostat can achieve. So for example, the normal thermostat, let's say for AC units, as an example, if you set the temperature at 24 and the room is 28 degrees, when it reaches 24, it will signal that it needs to cut off the AC. However, the response, like for the thermostat to pick, it might reach like 22, whereby at that moment it will switch off the machine, the AC, the indoor unit. But it will have like become uncomfortable for the equipment because it became too cold, and that could take like 2 to 3 minutes or even more. But with the BMS, like sending the thermostat or temperature sensor directly to the BMS, it can be sensed and acted upon more accurately and swiftly. So like this example I've given, like when the temperature reached 24, even slightly before it reached 24, BMS will send signal to cut off the EC. So here, like a simplified diagram for buildings showing systems, integrated systems to the BMS, the elevator, the power and lighting, heating and ventilation, and fire protection, access control, and closed circuit. So that is for the BMS. Now, I'll move now to a smart HVAC for energy optimization. Now, maximizing energy efficiency in HVAC system. So, like the optimization is or the edge VEC, in fact, is responsible for maybe the major energy consumption on buildings. So if the system, the edge VEC system, can be optimized, like it will be significant achievement in terms of what can be achieved in buildings in terms of energy consumption. So what is smart edge VEC system is about? Like it's about enhancing control, monitoring, and optimization, and reducing energy consumption and improving efficiency in building. So this wasn't really like possible before like developing building management system. But now the BMS system has been invented for, I think, over 25 years, and the prices like become more affordable than before. So here we can see like one part of the HV system for chilled water, where we'll have an indoor AC unit, and it has a control valve. This control valve like evolved over the last 40 years. So before it was just on and off. So either we'll have full flow or off, no flow. But over time, like with technology evolvement, we have now actuators that can open the valve just the portion required to air condition the room. So for example, if we're looking for a temperature of 24 degrees, and the room is 28, this thermostat will command the actuator to open fully. Now, when it starts coming down, dropping from 28 to 27, the thermostat will request from the actuator to close by 25%. So the closer the temperature, the actual temperature of the room, get closer to the setting point, the more flow throttling will occur on the valve. So this is part of like energy saving in modern buildings. So selecting the control valve is one of the like important points needs to be taken into consideration when looking for energy optimization in HVAC system. So also the thermostat, like modern thermostats, are interfaceable with the BMS system. Like let's say, for example, in hospitals or hotels, if a big group of rooms are unoccupied, it would be so hard like to send a attendant to switch off all the EC. So there's a feature on the BMS will override the thermostat and can control like the whole system to switch it off or to switch it on from the BMS. So this is another way also to achieve energy optimization through BMS for smart HVAC system. Now the feature of the HVAC system, like it will enable remote controlling. Also, it will automate scheduling. So for example, let's say for a church, we'll have an event from 5 o'clock in the morning till 9. So this can be scheduled beforehand. So the HVAC equipment will switch themselves automatically through the BMS and will switch off the system also through the time schedule through the BMS, the pre-scheduled time. Now also it allows real-time monitoring. So if we have a problem, it will appear straight on the BMS system like an alert, and if discovered early, the maintenance team can act on it early, so the damage will be minimized compared to if it wasn't monitored and let's say the pumps continue working while there is a problem. So instead of burning the motors and losing them and having a long downtime, it will be just like quickly picked up by the maintenance team and rectified. And also it allows predictive maintenance. So the BMS will, in smart HVAC system, it like be pre-scheduled. So for example, for the pumps, there are bearings. Those bearings can serve around 5,000 hours before they start warning out. And if they worn out, what can happen? The main shaft can have misalignment, and it like the problem of changing, replacing those bearings can get to replacing a pump. If there is no like preventive maintenance, some way to tell the maintenance team it's time now to change the bearings. So this is achieved through BMS system, and it is part of the cost optimization. So instead of getting into big troubles, costly troubles, it will be just like a message coming up. It's time now to change the bearings, to change the water seal. And the same applies also for the filters, like for the EC units. So all of those will pop up automatically on the BMS system for the smart HVAC system. Zonal control, which I've just addressed before. And all of this is through integration with building automation system like the BMS can be achieved. Now, integrating HVAC with building design. So the best, like it will be right from the beginning, from inception, from the design stage by the architect, like to have the HVAC design on mind and to find ways to optimize energy. So that can be achieved by, for example, ensuring selecting materials that will help on energy conservation. So, and the least heat transfer or heat gain, depends if we are talking about heating or cooling. Of course, also it is for the electromechanical designer, like to help on the design stage on how to optimize and like to ensure that the building will is energy optimized. So, for example, proper system design and sizing. Like, let's say, for example, if a room of 20 square meters required, let's say, 1 ton cooling machine. So selecting 1.5 tons machine will do that job, but it will utilize more electricity. So selecting correctly will save the energy bill in the future. And of course, will reduce the electrical cable sizing, the generator sizing, the diesel or fuel consumption of the generator. So here are the main goals, like for having HVAC energy efficiency benefits. So we have cost saving, environmental impact will be reduced, occupant comfort will increase, and the system performance will also increase. Here are another advantages for smart HVAC system. Optimizing HVAC scheduling, demand response, participation, fault detection, and chillers plant or the cooling system overall optimization. All right, we also optimize HVAC scheduling. Okay, sorry, this is duplicate. Apologies about that. All right, so a smart system for energy optimization. All right, I'll move now to the next topic. So now about renewable energy for buildings, namely the solar photovoltaic and battery storage integration to buildings. So the solar photovoltaic basics, it works by like through the sun, through the photovoltaic effect. So it converts the photon coming from the sun into electricity. It converts it to a DC, which is not in line with the electricity we use. We use AC current. So this diagram shows that from the solar panels, we have a charge controller, and then we have the inverter. This inverter will convert from DC to EC, so we can use it for our gadget at home. Now here, in terms of renewable energy integration, this diagram shows like where the solar photovoltaic stands out of the rest of renewable energy, and it's obvious like it is second to the highest after biomass, and like it's considerable, and it shows that the trend is for solar photovoltaic. Now, the type of solar photovoltaic system, there's the type of grid-tied, and the grid-tied like is connected to the grid, and at the same time is connected to the building. So it can serve both ways. If there is excess, it will serve the grid, and if there is no excess, it will serve the same house or building it's installed for. Now, the other one is off-grid system, and this one is practical for remote areas where there is no national grids available. And there is another third type, hybrid system. So I think this best to be shown on the diagram. So this is the hybrid system, and it shows that after getting power to the inverter, so it can supply the home or supply the grid or be fed from the grid. And if it is fed from the grid, it can store electricity on the batteries. And then the batteries can serve, when the grid is off, can serve the home. Now, the modern building design, or the technology now allowed different types of integration for photovoltaics. So, for example, here on the left, we see the rooftop photovoltaic. On the middle, we see building integrated photovoltaic, and it comes with various design. And the solar thermal system. The solar thermal system is really not photovoltaic. It works in different way. So addressing key challenges, the initial cost usually is high. The space constraints. So those are the things usually architects are concerned about. Intermittency, because of the sun availability during the day and across the seasons. And of course, the maintenance, because it's not like there are much of expert on maintaining the solar power or photovoltaic, I mean. So the benefit of solar photovoltaic and battery storage, reducing energy costs, increasing the energy independence, and having backup during the outage, reducing the carbon footprint, and of course, like this is applied to Europe and the US, potential revenue generation. So if the owner can feed the national grid, they can generate money from it. So other advantages, reduces the utility bill, and also it is like long-term saving system. So it can last between 5 and 10 years. And another important advantage, it can increase the property value. So this is about photovoltaic. Now, the last slide is about energy modeling. So this is also a very, very important, a bit sophisticated method, but thanks to the new software, it became like easier than before, and it became also more affordable. So energy modeling is the process of creating a like a computer-based representation of building energy performance. So this is best maybe when we see it on this diagram. So for example, this building, like if we use energy modeling software before it is constructed, and not relying only on the available climate data, especially for the HVAC system. So after modeling it, it can show clearly where are the spots that the heat will transfer from mostly, like those most red, and they will be acted by the HVAC designer together with the architect to find a way, like adding insulation, more insulation, or change the type of materials used there, the glazing, shading coefficient can be enhanced. So after they will analyze the problem and act on it, those red areas, they will become like between yellow and green. And that is like a great way and less costly way than reaching like the problem after constructing and then discovering that there's a lot of energy wastage or consumption. So the energy modeling is a computer simulations, obviously, and it analyzes energy consumption. And as I just explained, like from it, we can analyze and find a way to optimize the energy and evaluate ahead the future performance and decide how to improve it at early stage, best to be during the design stage. So here is the energy simulation, and it shows the colors and like where it is darker, like it will be the most like energy consuming points or heat transfer will occur from those points. So this method or the simulations will help on predicting building energy performance under various conditions, just same like what I addressed on the slide before. So the key benefit of energy modeling, it will optimize energy efficiency, will reduce the operational cost, and will support sustainable decision making at early stage. Now, a key benefit of energy modeling, informed design decision, cost optimization, and also like in Europe, it's part of mandatory processes during the design. So compliance with regulation and performance prediction ahead of construction. And also it is an opportunity to identify where there could be energy saving beforehand. Steps and process of energy modeling. So it's like standard process, defining the project goals, gathering input data, create energy model, which can be achieved through software, run the simulation and analyze results, and optimize the design to achieve the best result. And then it moves to the construction. Like the design can move to the construction. Now, addressing challenges, because it won't come smooth with everything. So data availability, like not all countries or all areas, they have data available or accurate data. Also, sometimes the buildings will have very complex model. It will be a bit hard to plug it in onto the software. Also, software expertise, that is one of the challenges. Uncertainty and validation. So here this proverb is the greatest shortcoming of the human race is our inability to understand the exponential function. And I put the meaning here of it. So like the energy use or resources depletion or even population often appears slow at first, but quickly become unsustainable and out of control. Same like the exponential function. Thank you very much for your time. This is the end of my presentation. Thanks a lot.
Okay. Thank you very much, Engineer Hani, for a very exhaustive and thorough session. I want to say thank you very much also to all our speakers, from Dr. Hassan Anifowose to Architect Opeyemi, Sina-Olulana, to Tomi Olatunbode of Spazio. Want to say thank you very much, and to our IT experts. I want to say thank you very much. Deeply grateful for all your diverse, input. I mean, it's been a very, very interesting and insightful session. Interestingly, we are unable to take the questions for the panel session because of time. We are on the dot of almost 3 hours. I want to make sure we conclude. And so, please, for the questions that you might have sent, we'll try and take them tomorrow, either on our YouTube page or we'll get them across to the speakers. I want to say thank you very much. And we expect, we're looking forward to seeing you tomorrow as we conclude the session. Thank you to all our friends all across the world. Tomi from Singapore, thank you. Architect, Dr. Azan from US, thank you very much. Architect Opeyemi from Nigeria, thank you. Our cybersecurity expert, thank you very much. It's been a very, very interesting session. We could have done it, without you all. And to our audience, thank you for listening. Thank you for staying through. It's been a very long session, but it's been very, very, rewarding and a very enriching session. Thank you, and God bless you. See you tomorrow.